When you measure the length of the pendulum, you measure from the base of the cork all the way until the center of the ball. I don't know if you know this or not, but most of the time, they will give this instruction in the soalan. Hey everyone, I've got news to tell you all. I found that one of the state paper past year came up pendulum, which I think might be very familiar. So why don't let's have a look. Now this is a pendulum experiment for the Pahang paper in 2022-2023. So it was a pendulum, and the good news is they actually gave with the full procedure. Now my recommendation is, if you cannot remember very long procedures, you can study this Amali punya procedure, because this is part of the state paper, which is a very reliable source of answers. Okay, so in this video, I will also discuss about things like how you should measure your reading, and also what are the decimal place involved, and how many decimal place does a stopwatch need to put. Okay, so let's start. Okay, now for this experiment, now when you look at the experiment, guys, always check a few things. Number one, what is the degree? Number two, did they tell you how many oscillations? Now let's say that this is going to be an unguided experiment. So if it's unguided, then macam mana? So this is why I stress out that you have to remember and memorize this given procedure. Guys, I repeat. Now, I'm going to make a very bold prediction. I think that your Amali will be maybe semi-unguided, meaning to say that they might give you a few procedures and you have to write the other few procedures. So it will be like half like that. This is why you need to know the flow. You have to faham the flow. You cannot just bulat memorize everything. So maybe they give you the second one, the third one, you have to write the fourth one, the fifth one, or something like this. So guys, always check this formula. Look at the whole exam paper if they give you any formula. It's because if they give you divided by 10, it means that you have to use 10 oscillations. That is the time taken for each oscillation. So check your oscillation, check your degree, and most importantly, guys, what stopwatch are you given? Okay, so here I will share with you. If you are using an analog stopwatch, so remember, analog stopwatch, right? This represents 5 seconds. Okay, but when we write our reading, remember, so because you see, right, if this is 5, this is 6, this is 7, this is 8, this is 9, so you need to know that every one of this line actually represents 0.2. So if your needle now point towards, let's say like this, then this will be 5.8 seconds. Okay, an analog stopwatch only has 1 decimal place. So when you record your reading, you cannot write 2 decimal places. The sensitivity for an analog stopwatch is 1. So when you draw your table, it will be 1 decimal place. But if your school teacher gives you a digital instead, so what is this? Okay guys, remember, you just imagine that there's going to be a dot here as well. So this is 6.31 seconds, meaning to say you have up to 2 decimal places. So you don't have to go around and ask your friends. So how many decimal? Because it will be based purely on the apparatus that you are given. Okay. So the second thing most important that you have to check, the degree, the oscillation, the decimal places. Second or third thing you have to check lah. So that's why sometimes you will see your friend punya jadwal, the table here, only 1 decimal place. Sometimes it is 2 decimal place. Based on the apparatus that you use, you will get 2 different table with 1 decimal place if this is the analog stopwatch. This is if you are using the digital stopwatch. Okay guys, check this out. And yes, I encourage you to write an additional decimal place here. So for your t-square, you can use up to 3 or even 4 decimal place, but I think 3 is good enough. Okay, so check depending on what stopwatch you have. Now, while doing the experiment, what tips can I give you? Now, so check this out guys. Okay, so first of all, ensure the loose end of the string does not obstruct the movement of the pendulum. So this is your actual pendulum. So you will have an extra string that's hanging on. So make sure you ikat this thing behind. Don't let it collide with the moving string. Okay, so I think it's pretty common sense, right, this thing. Okay, number 2, when you measure the length of the pendulum, you measure from the base of the cork all the way until the center of the ball. I don't know if you know this or not, but most of the time, they will give this instruction in the soalan. Okay, you check this out, guys. Okay, you check this out. You will see that they actually use from to the center. So you respect the question. If the question draw like that, then you follow. But if let's say the question draw the line until this part only, okay, then congratulations. You do not need to take until the center of the ball, the pendulum, the plasticine or whatever lah. Okay, so that's another one more thing to check. Okay, the length of the pendulum has to be measured from the bottom of the cork to the middle of the ball. Now, what about the third thing? Okay, so remember, we measure agak-agak to the center of the ball. Okay, maybe you'll be given a plasticine ball, so probably it'll be harder to measure, but you agak-agak to the center, starting from the bottom of the cork. Okay, Ken? Now, next. So once you're done with this thing, okay, we're going to go all the way here. We will release at a small angle. So maybe they even tell you what angle to use. So usually we will take anything from 10 to 15 degrees, preferably 10 degrees. Why don't take very big? Because if your pendulum is going to be released through a very wide angle, it will cause your retort stand to shake a lot. And also if your pendulum starts at a very high angle, it will actually move faster, which then your air resistance will affect it even more. So we want it to be slow. Maybe they even ask you a KBAT question. Why angle must be small? Okay, which I will discuss later. So therefore, so that I can reduce the effect of air resistance. Understand? Yeah, so you can see the air resistance is significant, and then the swing is unstable, the retort stand will shake. You can see the retort stand bangkok a bit already. Okay, because the pendulum will try to drag it. Now, finally, when you measure the time taken for the oscillation, always make sure that the swing is in a plane that is stable first. So my recommendation, guys, is never measure the first oscillation. Now, let's just imagine. Okay, wait, guys, let me find if I have anything or not. Okay, just imagine this is the pendulum. Okay, guys, for example. Okay, so when you displace this thing and you let go, okay, you will realize that the first two oscillations, maybe the thing will, you can see now, it's like spinning a bit. So it's like a bit marbled like that. So it's better that you let it swing, you let go, come back one time, come back two times, then only you start the stopwatch. Okay, so you let it to be more stable first. If you take the first oscillation straight away, you let go and then you measure, sometimes you will accidentally push the pendulum, which will cause a little bit of inaccuracy. So don't worry, guys, 10 oscillation, sure can one. You just let it go, maybe 1, 2, when you're ready, then only you start the stopwatch. You count. One complete oscillation is there and back. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Then you stop. Okay, Ken? So therefore, these are the things that as a teacher, I can advise you to do. Okay? Make sure that your clamp is tight. If it is not tight, you try to use the loose end of the string to tie the clamp again, so that it will be tight. Okay? So now you have already done the Amali. Okay, so you do already. Okay, so immediately put your protractor here, guys. And then measure your angle from the middle like this. Okay, measure the angle of this place. So now we can finally do our soalan. Okay, so let's start. So based on the experiment conducted, state the responding variable. So you see, this question is interesting because they never give you the aim of the experiment, not to find, it's like to determine the value of gravitational acceleration g by using a pendulum. So guys, if you're watching this video, right, can you reply to the comment after Monday if the Amali that comes out in your exam, is it the same as this one? Okay, I would appreciate anybody who can, drop me a comment even after the exams. Tell me if it's the same. So maybe you do not have investigate the relationship there. So what you have to do here is you just see, okay, since you're going to use L, so L is known as what? It is the length of your, sorry, this is your manipulated variable. It will be the length of the pendulum, comma L, and your responding variable will be the period of oscillation, comma T. So check this out. So we use capital T to represent one oscillation, small t to represent the total 10 oscillations. Okay, to represent the total 10 oscillations. What about the constant variable? Okay, there's an answer that I prefer, and there's an answer that is a maybe can. I mean also can lah. I will write the angle of pendulum displaced. Okay, now why? Because what is the thing that you have to make sure, that you have to pastikan that you cannot change, that you as a person cannot change, okay, the angle of pendulum displaced. So if you use 10 degrees, okay, if you displace the pendulum 10 degrees, you have to make sure every time 10 degrees, because if you do 20 or 30 degrees, the time taken will change, okay. Now there's another one more answer that banyak orang say. For me, I've written this in my exam before, gravitational acceleration, and then my teacher actually gave me wrong, because his argument is that yes, gravity will affect the period of oscillation, I know, but he said, can you change gravity? Can you modify gravity? Can you memastikan that the gravity is the same? No, because gravity is always the same, so you cannot change it. That's why it should not be one of your variable, because you cannot vary gravity. Okay, so I prefer the angle of pendulum displaced, if you ask me. Okay, for the next part, we're going to talk about the Amali punya data. Okay guys, can. Now, there's this rule punya, alright. Now, if your data is wrong, never mind guys, just let it go. Okay, because now, by the way, this one right here got a bit cacat already, so we ignore this one. Okay, I'm going to use this data as a reference. Okay, so you check this out first, you will see. Now, if you see, right, different people, when we do the Amali, right, we might have a bit of different. Maybe you get 22 seconds, maybe I get 23 seconds, maybe your friend get 26 seconds. So the answer with a certain degree of discrepancy is normal, because it is a practical exam. So guys, don't stress, don't stress over this. Okay, so what you're going to do right now is you're going to divide this by 10. So why? Because you want to find the time taken for one oscillation. So you divide by 10, 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 and then you square everything here. So you just square this, square this, square this, square this, square this, you will get the following answers. Guys, I invite you to, press your calculator a few times and see if you get this or not. We will use 3 decimal place and we will do our, our graph lah, okay? So now, if you plot this out properly, you have 5, 6, 8, 10, 11.499. Okay, so you have to draw your graph of t squared against L. Okay, so here, what I'm going to do right now is I will show you and I will do the graph with you. Guys, if possible, I highly recommend that you draw the graph with me. So I know that you all will waste a lot of time by doing the 1, 2, 3, 4, 5 like that. Okay, so just very quickly, I count here got 1. How many graphs do I have? Okay, how many points lines do I have? Each point to be 1. So do we recommend you to draw your tepi like that? The answer is yes. You can write your 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, do you if the scale is given in exams, I will recommend you to just write all the way up. Okay, if the scale is given now, because this one scale is given, and then after that at the bottom, okay, let's count first. We got 1. Okay, we got like this. Okay, so got people ask me before, teacher, can I straight away start 30 cm? Since my L is 30, then I can do 40, 50, 60, 70. Am I allowed to do it this way? The answer is no. You cannot do the broken, the lightning, the Pikachu punya tail, that thing cannot. For physics, we have to follow everything step by step. So if you decided that you use this as 10, you use this as 20, you better make sure 40, 50, 60, 70. Okay, very good. So enough space. So are we allowed to use the last point? Yes, if you're curious about this. 50, 60, and also 70. Okay, so now let's plot the graph together. Okay, now I want you all to please download the file and do it together. Okay, so now our t squared is 5.33. Okay, so at 30 cm it will be 5.33, so it will be located somewhere here, 5.3. So every one of these box represents 0.2. So 0.3 will be 5.3, so it will be somewhere in the middle. And then 40 cm is 6.8. 6.8 should be somewhere here. Then this is 8.3. 8.3 will be somewhere here. 8.2, 8.3. Then after that, 10.01. 10.01 is very close to 10, so I can just straight write like 10 there. And then followed by 11.5. 11.5 is like just somewhere between 11 and 12. So therefore, this is my point, okay? Now, since we know that pendulum will always start from 0, so we main tipu sikit, you straight away start from 0 here and then you draw your points, okay? Now, remember, your aim here is to pass through as many points as possible, but that's not the main focus. Your main point here is to divide the points up and down equally. Okay, guys, check. Okay, so I have a point which is located at the bottom, a point which is located at the bottom, a point which is located on top, and a point which is located on top. So make sure that your point is not more than 3 boxes away, okay? Make sure that your points are not more than 3 boxes away, agak-agak like that. So this would be a very, very perfect punya line of best fit already. So make sure you write your 0, make sure that you have your title as well, check your this thing, check your unit and the full name, you will get your graph easily correct one. Okay, Ken, boleh? Okay, so now I'm going to put my graph on the sides, we will continue. Okay guys, let's just ignore this graph lah, because this is the answer given in the state paper. Okay, then they want you to calculate the gradient of the graph t squared against L. Okay, what should you do? It's 2 marks. Okay guys, 2 marks. Now, so if you see this part, okay, you have to first pick your 2 points. I'm going to pick my origin, and I find anywhere it's easier to measure. I realize that this point is quite satisfying because it so happened lies quite closely in somewhere. It lies very closely to this part, okay? And what point is that? That is your 11.8. So I will use 70 cm and 11.8 as my answer, as my point, and then this I will just take origin 0, 0. You need to draw the dotted line that goes all the way down, okay? Some people say use solid line, some people use dotted line. I really think it doesn't really matter. Then after that, you just draw the line over to the other side. Okay, make sure you plot this 90 degree to show that that is your triangle and label your points. So 11.8, 70, 0, and 0. Remember, the point that we take is on the graph, the best fit, not the coordinate of the x, but the point of your best fit here. So which is 11.8. Okay, guys, sorry because iPad sometimes the line very hard. They will auto correct it to become a straight line like this one. So it's like not very straight. Okay, so now calculating gradient. Okay, we will then shrink the graph first. Okay, we have y2 minus y1, x2 minus x1. And then after that, what should you do? So my coordinate is 0. My y-axis is 11.8 and 70. So I will take 11.8 divided by 70. So my coordinate is 0.1686. Okay, is 4 decimal place acceptable? Yes. And what is the unit? Now, because the unit here is in S square, because the unit here is in cm, so what we will do here is we will take the S square divided by cm. That's why I have S square cm negative 1. Okay, so that's how you get. But guys, of course, your gradient value and my value might be different at the end. Mungkin after will be different, don't worry. Okay, so menggunakan this gradient, please find the answer G and in SI unit. So what do you need to do here? Okay, check this out guys. Do you remember they gave you a formula? No, they didn't. Here, the formula is here. Okay, so they give you the formula. So remember guys, my advice is compare the GG. What is GG? Compare given and graph. Graph versus given. Now, remember, you have to use the gradient of the graph. Now, I see before teacher, right, when they teach how to calculate this part, they call you to pick points in the graph, sub value into the formula. Cannot. You must use the gradient because they already say using the gradient. Then you use the gradient lah. Okay, so what was my graph, guys? My graph was t squared against L. And it is a start from 0 punya point. So, according to my graph, it will be t squared equals to ml. Why? Because this is based on y equals to mx plus c. So this is 0. Then my x-axis is L. My gradient is m. So t squared equals to ml plus 0. So finally, I summarize it. I get t squared equals to ml. Now, berdasarkan the formula that is given, t squared equals to 4 pi square L over g. So now I want to do a comparison. So how to do this comparison? Very simple guys. If you find it very complicated and if you maths not very good like me, you just cut t square cut, L and L cut. So what is remaining now? Your t square cut already, your L cut already. So you are remaining with the symbol m. 4 pi square over g equals to m. What is your m? Your m is your gradient. So your gradient is 0.1686 S square cm negative 1, guys. I'm going to write the unit in the gradient calculation here. Okay, you will understand why later. So 4 pi square over g. So if I calculate g, I have to take 4 pi square divided by 6 S square cm negative 1. So up here now, my g value will be what? Okay, let's sort the unit out first. So this S square cm minus 1, I need to pindah atas, right? Correct? Because I divide this. So my cm will become positive 1, then my S will become negative 2. Okay? Now, if you cannot remember this thing, never mind. You just need to know that this is an acceleration. Acceleration is either ms negative 2 or cms negative 2, correct? But in this Amali, because you are doing it in terms of cm, okay, your length of pendulum, that's why when we calculate out, it will be cm. So then, when you have to calculate this 4 pi square over 0.1686, teacher, should I use which pi? You can use calculator pi value, guys, it's okay. So I'll demo and show you I'm using the calculator pi. So I get the answer to be, 4 pi square over m, which is over the gradient. So 4 pi square over this, I get 234.154 cms negative 2. Okay, now can, why the answer so small now? Okay, never mind. So only itu up here now, my g value, because they want me to do it in SI unit, I only managed to get 2.3415 ms negative 2. So you guys know how I go from here to here, right? Because cm changed to meter, so I'm going to just divide by 100. Okay, I know this is going to be a bit messy, but guys, take your time and process this information because this is so important. Okay, Ken? Okay, okay, so if you guys are okay with this, and then last but not least, you're gonna have some KBAT question at the end. Oh yeah, guys, what if they ask you for the relationship? Okay, guys, there are two relationships here. If the rule in physics, there's a graph and no graph situation. So if there's a graph, guys, which you already draw a graph, you just have to you just have to write t square is directly proportional to L. Okay, because the graph starts from 0. But if there's no graph, I know this sounds a bit absurd, but what if there's no graph? Then you just have to say as your t square increases, your L increases. Good enough. If there's no graph, what are the chances of no graph? Less than 5%. Okay, Ken? Now, so once you're done with this thing, okay, I already talked about relationship, I've talked about this thing, I've talked about how to calculate your G value. One more KBAT question. Okay, I'll give you a few KBAT questions here, guys. Okay, number 1. If now you carry out on the surface of moon, can you tengok lah formula to 4 pi square L over G. So if you go to moon punya gravitational acceleration is lower, correct? So if your denominator decreases, the time taken will increase, right? Why? Because you will take longer time. If your gravity is weaker, the pendulum will be slower. So therefore, you just have to write the period of oscillation, T will increase. The period of oscillation T will increase. Okay, guys, bonus F. If the mass of pendulum increases or decreases, what will happen to the period of oscillation? Please remember the answer is your period of oscillation T remains the same. Okay, now guys, I'll give you the bukti why it remains the same. Because when you swing a pendulum all the way down, you are transforming the gravitational potential energy to become kinetic energy, correct? So if you use mgh equals to half mv square, the velocity of your pendulum is not important. It is not the velocity of the pendulum mass is not important because you already potong. It is only affected by gh equals to half v square. The velocity of your pendulum is affected by the strength, your gravitational field strength, and how tall you drop your pendulum. So mass of pendulum box doesn't affect anything. It will remain the same. That's why mass of pendulum is not a suitable constant variable. Okay, so going back to the front part, Constant variable, I prefer angle of pendulum displaced. Okay, and then one more thing. Okay, guys, what about another KBAT question? Okay, if they ask you why do we use 10 degrees and why don't we use like 20 degrees, 30 degrees? So remember 10 degrees so that the velocity of your pendulum is lower. So if your velocity of pendulum is lower, means that the air resistance, the effect of air resistance will be lesser or lower. So which means that because if you go slower, the air is less likely to act on the object. If you go very fast, you will have more air resistance. So if they ask you why prefer to use lower angle, that is your answer. If why, they might even ask you why your answer might not be accurate, because there's effect of air resistance. So one major part that you have to know, guys, remember, so conclusion, length is always 1 decimal place, 30.0 cm, because of your meter ruler, okay, British meter ruler. Then your stopwatch T depends on what stopwatch. If your stopwatch is the analog punya, it will be 1 decimal place. Okay, if your this one is 2 decimal place, and then you have to know this is digital stopwatch if you use 2 decimal place. And then after that, last but not least, guys, protractor got how many decimal place? Protractor, no decimal place, so don't write 0. So guys, this also applies when you are writing your procedure as well. That's why you see later on when you write the procedure, you will realize that everything here we will tambah 0, tetapi when we write angle, we never put the 0. Even here, length is 0, you must match the apparatus that you use. Okay, what about precaution? The precaution is always the same. Okay guys, listen, your eye level must be perpendicular to the scale of the meter rule to avoid parallax error. Okay, so which you can check the description below. So those kind of words stuff I will put in the description, which is all those factual stuff. So thank you everybody for your 20+ minutes. I wish you guys all the best for your Amali, and if possible, drop me a comment, and I hope you support this channel even after you graduate. So thank you everyone. It's been a pleasure. Some of you, this might be the last video you'll ever watch. So yeah, do drop me a subscribe and a like. So thank you everyone. Bye bye.